We're recording again. This time I'm thinking I'm just gonna go for things I like to do. Basically, I'm not really interested in talking it like a linear step problem. We're just gonna go straight up to portions that I like to talk about. Is what my initial thought is gonna be. But I decided I'm just gonna go randomly over here. I'm just gonna do something like there. So it looks like we're gonna talk about exponents instead. So fun. Exponents. Yeah, they're pretty fun things to talk about. Anyways, last three videos I had to it was a mess. I kept on deleting it and redoing it because I keep on not getting what I want from it. So that was fun. I have a bunch of videos now that not usable, so one way or another. Anyways, let me see where this is. All right, we're over here. Okay, that's good enough for me. Okay, we'll start here. So let's start by proving that AM equals AN plus M. Um, I never explain what N and M is. N is integer like this, and M is an integer like that. Is what I would say. The Yeah. And you'll see how fractions are created from this later on. But for now, we're going to assume that fact, because this allows us to say, is that visible for you guys? Let's go a little bit closer. Uh, that allows us to say something like A1 multiplied by A2 multiplied by A3, so on to AN multiplied by A1 multiplied by A2 multiplied by AM. Therefore, we could say that is true. We proved it. Um, um, Now, I said integers here. Now, if the next proof goes on to say AN over M equals AN dot M with a multiplication here. Now, with multiplication and division, A AM and N equals AN minus N divide N minus N, right? Yeah, right. That is right. But we can determine by the same rule as that one over there. So we don't really need to talk too much about that. But what's interesting is the multiplication one, where we say that because I already kind of showed you what it is. It's just basically having term of 1, 2, 3, 4 to AN into M and so on. I show that proof. But so far we have assumed integers, but using this factoid over here, we can say that N is an integer Z and M is integer Z. Creating it, we can get N as well. Well, I was trying to think of something. Oh. We could say something like -2 here, and then we can say 4 over here, and then that's -8. That doesn't work. Okay. I was trying to prove something about non and oh, am I thinking of this? So we could also say from this proof that AN minus AM equals AN divided by M. Yes, right? We can inverse it. No. Yes. No. 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 That's wrong. That's wrong. That's wrong. We can't say that. It's negative NM, right? Um, yeah, yeah, I'm wrong. Sorry. So no, so yes, so no. I'm trying to prove something right now, with integers. So that won't work. Okay, I guess I have to just destroy that idea. That is totally wrong. I'm wrong about that. So there you have it. That is it. A very basic, boring proof. I don't really like it. Um, I mean, I like it, but I don't really need it. Let's go to something else. That was boring. Geometry may have some interesting proofs. Um, trig. This is trig. Um, okay, we have a triangle base plate proof. Um, so the first thing we need to encounter is this triangle here, which is a special triangle, as most people know it. Okay, so what am I trying to get here? So if you get the sine of C over here, that equals H over A, which makes sense, right? H over A. Why? Height, height. How do you get height? Height. What the hell am I writing here? Oh, that's the wrong thing. I was wondering, like, that doesn't even add up. What the hell am I doing? And I realized that I should have probably made this better. Insert horizontal line, please, because by God, I don't understand what the fuck was going on in my brain when I thought that was okay. Okay. Oh, I definitely need to rehaul this shit. This is like painful to read now that I'm looking at this and saying, okay, that is a little painful to read. Was this not part of this part? Really? Okay. That's fine. I'm gonna have to change this whole thing anyways because it looks awful. Um, I'm gonna change that real quick, but later. Highlight, change this. I will change all this later because it looks awful. What section is this actually? Control minus this section. I believe it's trig. No, it's geometry. What geometry? I did this shit. Okay, fair enough. Oh, well, that makes kind of sense actually. Um, this is what I want, but we'll see. Oh, projectile motion question. We can do that. It's not really fun. We can also do that part. Oh, that was so much fun. Okay, maybe I gone too too slow. Um, yeah, this sounds like a fun quote. No, that's so awful. Oh, I always like this proof. This proof is fun, but the funny part is, you can prove it for partial. It gets annoying when you do proof for partial or something. So it gets pretty annoying later on in life. Ooh, this proof is also fun. Let's do the product rule proof. Yeah, the product rule proof. I don't think a lot of times I do this one. So d x parentheses fx and then gx. We know this product rule. Maybe we can expand it to something else too because I keep on thinking about it. But let's just, for some reason, add HX2 because the product we'll just continue it a little bit more because I know what it's supposed to look like if I do this. Let's see if it happens to be like that if I do it this way. Now, we all know what this is. Basically, it's the limb of H goes to 0. Oh, wait, maybe I should change this to R or something. Um, lim as h goes to 0 of basically fx plus h and then gx plus h. And now in this case, we have rx plus h divided, and then we just have to continue this because we also have we'll continue. Okay, why is my tablet not working now? Okay, now it's working. Now we continue, and then we say minus fx and gx rx is what we normally do. And let's just see my things. I think that's still visible, right? Maybe here. And then h on the bottom is what we have. Is what we normally have. And what we do usually is, what do I usually do anyways? I I get, oh, I see why we don't do three more, but you can kind of see why it would be the same. I'm gonna just do a notation like this follow. Um, this whole thing is equal to A, this whole thing equal to B, because I can. Because I can. Yeah. That's a horrible accusation. No accusation, a horrible way to do it. Um, but you can see that A and then B is over here. And the middle, what you do is basically say, well, get f of x plus h, and then get the other f and r, and then this will be minus, and we have a plus over here of f x plus h. And then we have G and R basically again. And you can see the pattern you get here, it looks like, right? You just add another variable. And from this, you can move all the F, S plus H. I'm just thinking of how to solve this with three of them in. Because I know what it should look like. The three product, I know how a three product will should look like. It's just doing it three times. Anyways, we have this over here, just over here, we have this over here, right? Am I wrong? No, I think I'm wrong. No. So we have G of x plus h, and then we have R of x plus h, parentheses. We have minus G and R, and then divided by h. We have transfer information over here. And then we have over here plus G of x over here, divided by h. Do we have G of x here? Look at this. Oh, pretty sure we do. Yes. I did this wrong. I think I did wrong. I did this wrong. Yes. So wait a second. Something is fishy over in Fisher McFishtown, but we'll figure it out there later. And over here, we're gonna have basically the other suitors, right? Okay, I kind of see the big problem here. Okay. Man, it's gonna be a pain in the ass. Okay, fair enough. We'll do it because I said I'll do it. We're gonna do it. Um, I didn't expect it to be a pain in the ass to do this, but we'll do it. Ugh, my God, why doesn't it want to work? So again, we'll see over here that the next thing we do. All right. How do you transform the more? No, we know that this is true. Wait, so what? So what are you supposed to get basically is if you have a 3 like this, you're supposed to get basically d, g, dx, and then rx, and then so on 3 times. So let's see if I can get it. So let's say this is fh, gh, and rh for simplicity minus fgr divided by h. Well, a limit over here, but we won't write that anymore. This is annoying the hell out of me. Then we get over here, and then fn, gn, rn. We can add and subtract all the time. So we're going to use that strategy over here. And then we'll say, okay, we can add in maybe a fn, and then maybe a gr like normal, plus fngr. Let's see what this will do. fgr. And we'll just get rid of the h on the bottom for now. We won't use it until we get certain things running. So fn is just parentheses and get fn minus this. So we have GHRH minus GR. We keep G by N I mean H, you know what I mean. And then we have over here the leftovers. We have plus, and then let's grab it toward GX over here. G. And we have FN uh R plus we is it plus? No, this is minus. This doesn't make sense. I'm mentally thinking doesn't make sense. F and G R, which G is gone, so this is it. And if I do a H over here, and I have a limit over here, um, we know for a fact that if we move this over here, that is Fn, and it's the derivative of GH, no, derivative. So what we have so far is let me show you what I'm trying to say here. This makes perfect sense. F H, so x plus h over here by a limit of h goes to 0, right? So we have g parentheses x plus h basically, and r x plus h, right? Minus g, and then this is x plus R, no, not R, not plus, R parentheses, and this is the first one, right? And divide by H. We know this goes to this H goes to 0, so and we can move out the fx by limit, and this is only the first term, so don't forget we're only looking at this term over here first. And then we'll move on from that later. So this is g s plus h and then r x plus h minus g x r x divided by h. So that limit, this is a derivative. So we know that this derivative is g r dt. That's a particle, right? So fx. Now the second part of it. Let me go this way. The second part of it is this portion over here. We'll get that portion right now, actually. So it's Fn gr minus Fgr. Now you can already see that gr removes out, leaving Fn minus F. And remember, we're doing divide by h here, which if you take a limit of that, h goes to 0, we get derivative of derivative of f divided by dh, no, dx by g and r. So over here, if I plug this back into here, I have fx by d and g x rx, and this is parentheses by d x. This is supposed to be x. And then plus g parentheses x, r parentheses x, and then dfx, and then dx. There we go. That makes perfect sense. Now we move down from here. Now this is just a product rule, as you can see. And then we can get from that dg of dx, keeping the drx, plus we keep the dfx, right? And then we get the dr dx by g of x, oh, g of x. And then plus, well, we'll start with g of s this time, and df dx, and then plus r of x. Therefore, we get what I expected. Well, I expected that. That is the formal proof of that bullshit. Against. I expected that. I wish my handwriting was better in tablet. It's not. It's absolutely atrocious. But you get what I'm trying to say. You get what I'm trying to put down. Well, it's a harder version of this proof, but it's actually not that hard. So if someone wants to prove it, there you have it. There's your proof. There's your proof. I guess this, yeah. Maybe I can make that. Maybe I should have put the harder proof on there. Uh, this is technically the harder proof, but it's not really that hard. Yeah, I'm done.